And hello, my little mathematicians. Today we're going to write equations with both independent and dependent variables, meaning there's two variables, from stories. So, first off, let's kind of refresh. Remember that independent variables affect your dependent variables, okay? Or your dependent variables depend upon what you did to the independent variables. So a lot of times what I like to do is I like to say the phrase, this depends upon that. And whatever you say first, that's your dependent variable. And one way will always make more sense than the other. Okay. Um, Also, independent variables are your x's, right? So your independent variables are usually represented by x. And your dependent variables are usually represented with a y. And you're going to notice that our equations, okay, are y equals what we're going to be establishing here pretty soon, your rate times your independent variable. So a lot of times we do things to the x, right? So the x is the thing that I change. So independent variable, I change it. And then my answer, y, depends upon that. So why did I get that answer? Well, it depends. What did I do to the x? That phrase kind of helps you remember y is your dependent, it's your answer, and x is your independent, and it's the one that you normally do stuff to. And most commonly, like 90% of the time, in the equations that we're going to come up with, you're usually going to have it multiplied with some type of rate. Okay. So let's get back up to here. A rate is a number that compares the independent x and dependent y variables. So see how it compares, like what did you do to the x to get to the y? And we usually use your rate in that equation. When you're writing an equation, the rate will be multiplied with x or the independent variable. Rates are numbers that can often be found next to the word per, each, or every. Okay, so remember that again, your rate will be multiplied with your x, and it's usually found by the words per, each, or every. Okay, and it has both the x and the y in it. Okay, sometimes later on, they might notice that it's called the rate or rate of change because that's how the problem's changing, or they call it a constant of proportionality. So, um, if you look, remember how x and y's like represent graphs, right? They represent xy coordinate points, and the rate is the rate, the constant rate in which it changes. So like here, if it goes up 1 over 1 2, up 1 over 1 2, up 1 over 1 2 to get from point to point, that's the constant of proportionality. So they also call it the slope. Later on, you'll see it y equals m times x, or y equals k times x, where m stands for the slope and k stands for the constant of proportionality. They're all saying the same thing, potato, potato. You have your dependent variable is equal to your rate or constant of proportionality or slope or rate of change times your x, your independent variable. Okay. Even though it might be called something in later years, it's still the same thing. Okay, so first of all, to give us some practice with this, let's write r next to the rate in your problems, x next to the independent variable, and y next to the dependent variables. Once you identify what each of those are, then use it to go y equals r times x. Okay, and we can write our equation. And they're normally going to use the directions. Please write an equation that expresses y in terms of x. This is me expressing y in terms of x. What did I do to x to get to y? Okay, so if I look at this problem, it's saying Skylar rides her bike at a rate of 14 miles per hour. Um, at that rate, how far will she have ridden her bike? Hmm. What do you think? Okay. What depends upon the other thing? Is it how far she rides depends upon how long she's been riding, or how long she's been riding depends upon how far she's ridden? Um, how far she's gone depends upon how long she's been riding. When you just start your bike ride, you haven't gone very far. But as you go further in, hopefully your distance has increased. You've gone further the longer you ride your bike. Okay. And a lot of you are like, yeah, that makes sense. And then others of you are like, I don't know that I could have gotten that. So let me show you a trick. Okay. Remember how earlier we said the rate is usually represented with per, each, or every? So if you find that in your problem right here, okay, per, each, or every, and it has a rate relating your y to your x, it's in the form of y over x. So right here, your rate is the 14 miles per hour. It's that whole thing, okay? It involves both the y and the x. So that's how fast she rides. That's your rate. She rides at 14 miles per hour. And then it separates out to your y, or dependent variable, is the miles, and your x, or your independent variable, is the hours. Okay? So again, the number of hours is your x. Okay? And then your y is your number of miles. So your equation would be y equals your rate, which we found to be 14, times x. And there you go. That's your equation. For right now, we just want you to practice writing the equation. If you wanted to solve it, okay, y equals, and they told me y was the number of miles, right? So how far will she go? Well, we don't know. So that's going to stay a y. 14 stays a 14. But x, they told me, okay, well, how far will she have ridden her bike after 2.5 hours? So what if x, the number of hours, was 2.5? How far would she have gone? So then you just plug it in and see what your answer is. 14 times 2.5 is what? 35. So 35 miles is how far she'll go after 2.5 hours. Okay, but again, right now we're just looking for the equation. Okay, our next one says, when Carter's neighbors go on vacation, they ask him to take care of their pets. They pay him at a rate of $20 per day. Okay, remember how we said when you see that word per, each, or every, that usually helps me indicate that that's my rate. Okay, so there's my R. How much Carter is paid each day? Yeah, she's paid $20 per day. So that's my rate. How many days Carter watches a pet, or the total amount of money Carter earns. Which one's what? Well, how much I earn, Y, depends upon how many days I actually watch the pets. Or remember that little trick, Y per X. So Y is talking about the money, the total amount of money Carter earns, and X is talking about the days, how many days Carter watches her pets. So then my equation is Y equals my rate, which was 20, times X. Okay. When you write the equation, you always want to have your two variables in it, because the point is you want to be able to substitute different things in. Well, what if, I watched him for 5 days? What if I watched him for 6 days? What if I watched him for 10 days? Then how much would I make? So you want it so that you can plug different things in to get different possibilities. Or, hey, I want to make a minimum of $100. How many days would I have to watch it? Or I want to make a minimum of $50. How many days would I have to watch them? So things like that. You want to be able to keep these as variables so that you can change them depending upon what your goals are. Okay. In this particular problem, they're asking you, if Carter's neighbors leave for the whole month of June, how much would he earn? Okay. Remember, he's getting paid per day, right? And if they leave for the whole month of June, that's how many days? Well, it says hint, there's 30 days in June. So if you watch the pets for 30 days and you're paid $20 per day, then Y is how much money you're going to make. So go ahead and multiply that. 2 times 3 is 6. Tack on your 2 zeros. So Carter would earn $600. Okay, that's if we were asked to solve it. However, we just wanted you to write the equation. All right, let's try some more. Okay. Again, we want you to identify the independent and dependent variables in order to help you write the equation that expresses y in terms of x. So for our next example, it says Jason races his bike at an average rate of 23 miles per hour. How far can he travel in 15 hours? What's my rate? Well, remember that 23 miles per hour. So my rate is the speed of 23 miles per hour. And then that helps me identify your y per x. So x is your number of hours, which they said was going to be 15. Okay, and then your y was the number of miles that you traveled. And they said, how far is it? So we don't know. Okay, well, when it asks for the equation, remember, we want y and x to stay y and x so that we can plug different things in there. And then our rate is multiplied by it. And they told me my rate is 23. There's my equation. Now, for this particular problem, if they asked me to solve it, they said, okay, so here's your equation. Y equals 23 times x, where x stands for the number of hours and y stands for the number of miles. How far can you travel in 15 hours? Well, hours, again, we said was the x, so let's plug in 15 for x and see what that gives me for y. Well, 23 times 15 is 345, and y is miles, so 345 miles is how far you can go if I was asked to solve it. Okay, if you haven't tried to solve any or set up or solve any of these, why don't you go ahead and give it a try? Remember, pause the video, come back and join us after you figured it out. Okay, so you've unpaused it, you're back with us. It says Molly was able to break a world record by eating chicken wings at an average rate of 16.7 wings per minute. If her competition lasted 30 minutes, how many chicken wings did she eat? And that's a true story. That's actually a world record. Okay, so I know that you see like two different numbers here. Usually in the first part, it gives you the information you need for your equation. And then after you have your equation, then it'll ask you a question. Okay, so what if this, then what would the other thing be? Sometimes they give you the X, sometimes they give you the Y. Normally they give you the X, but you never know. Okay, so from the first part, that probably gives me what I need to set up the equation. So it says that an average, they even told me it was the rate, 16.7 wings per minute. Okay, so your rate is speed of eating chicken wings. And it was 16.7 wings per minute. That was the speed. Okay, now remember that it tells you your y per x. So x is the number of minutes spent eating, and then y is the number of wings eaten. So your equation would be y equals, what's my rate? 16.7 x. Okay. Sometimes they ask me to use specific variables other than x and y for your independent and dependent variables. So try writing your equation giving these different directions. Okay. It says write an equation for how many wings Molly eats. Use W for the number of chicken wings eaten, and M for the number of minutes. So where is it? W equals 16.7 M or M equals 16.7 W? Well, think about it. What was what? The number of wings eaten depends upon how many minutes you spend eating. As more time passes, you can eat more, right? So Y, your answer, is the number of wings. And then your independent variable, your X, was the number of minutes. And that's multiplied with your rate. So you're predominantly always going to use Y and X. So it's always like 99% of the time going to be Y equals something times X. And you want to use those unless they tell you to use something else. If they tell you to use a W and M, use a W and M, whatever they tell you to use. If they don't specify what to use a Y and an X. Okay. Now, if you were asked to solve this, it says if her competition lasted for 30 minutes, how many wings could she eat? So we don't know the number of wings, so that's going to stay unknown. But they told me the number of minutes was 30. So let's plug that in for the M. So now you have 30 times 16.7. And what do you get? You get 501. So that means that in 30 minutes, ew, gross, she can eat 501 wings. Okay. Again, if you haven't tried any yourself, please always pause the video, try them, and then unpause it and come back. This one says Isabella's cell phone plan charges her 25 cents for every text message she sends. Okay, so per each or every right there. Okay, and that separates your Y per X. So X, your independent, is your number of text messages. And your Y is the money charged or total she has to pay. Okay, your rate was that 25 cents per text. So then your equation, you should be an expert at this now. Y equals, what's your rate? 25 cents, so 0.25 times X. Okay, if you were asked to solve it, it would be Y equals 0.25X. Plug in what it is that you know. Well, they asked me if she just sent out 42 texts. X is the number of text messages, so let's plug in 42 for that. Then that will give me my Y. So 42 times 25 cents is 10.5, which in terms of money is $10.50. So she would be charged $10.50 if she sent 42 texts. Aren't you glad that we have unlimited texting now? I remember I got grounded all the time for sending too many text messages and I'd have to pay over the amount. It sucked. I was grounded all the time. So be grateful if you have a cell phone plan that's unlimited texting. Now remember, if they don't specify what to use, you should use Y and X. If they do specify what to use, then use those variables. So they said use T to represent the number of texts and P to represent the total amount she would have to pay. So we said the total amount she has to pay was like your Y. That depends upon how many texts you actually send. And then you multiply that with how much it is per text. Okay, and there you go. Last page. If you haven't gotten any right yet, this is your page. I can feel it. Okay, the only thing is we're going to add in one more new concept. Sometimes they'll also include what's called a constant into the mix. Okay, a constant is a number that will be added or subtracted in our equation. Okay, Some stories will have constants and some will not. They are usually, if you want to write down, like a starting fee or cost. So a starting fee or cost, or an initial fee, or a one-time fee, or a flat fee. So any of those things, like a starting cost, an initial cost, starting and initial is the same thing, a one-time thing, or a flat fee. That's something that gets added or subtracted because it just happens one time. And then the other ones happen however many times your independent variable happens. And that's why it's multiplied with your variable. But these are just added or subtracted at the end. Okay, so let's see if we can find the difference between the rate and the constant in this problem. Okay, it says Rodrigo goes to the county fair. It costs $16 for admission and $3 for each ride ticket. Write an equation for how much Rodrigo would spend if he went to the fair and bought some ride tickets. So, which one's something that happens like only once? Yeah, this $16 to get in. That's just a one time fee, right? So, that's a one time admission fee of 16 bucks. That's going to get added on at the end of my equation. Okay, that's different than your rate that gets multiplied with however many rides you go on. Okay, so your rate is the $3 per ride, right? And then which variable is what? Which one's your y? Which one's your x? Well, how much money you pay. So the total Rodrigo pays depends upon x, how many rides he goes on. So y, the number of rides, is equal to your rate of $3 times your x, which is the number of rides, because it's $3 per ride, plus that one-time fee to get in. This isn't multiplied by the number of rides. You just pay that once to get in. And then, depending upon how many rides you go on, you multiply that by $3. And that's equal to the total amount you're going to pay. And now you can kind of see how this all works and comes together. Okay, let's try another one. It says Kobe has $100 in his bank account. Every week, he saves $15. Write an equation for how much Kobe has in his bank account. What's the constant? Is there one? Yeah. So right here is this, he has $100 in his bank account. So your constant is the starting amount, okay? Because remember how we said sometimes like your initial or your starting. So the starting amount in his account is $100. Now, is this going to be added or subtracted? Well, every week he's saving this much more, so he's going to add this to his starting amount of $100. That's how much we have. And then our rate every week, he saves $15. Okay, now this is a little bit tricky because it's like, wait, the per each every, and it did my y per x. Imagine if it said $15 every week, because it technically could be rewritten like that, right? So it's still y per x. So y is the total amount of money in Kobe's account, and your x is the number of weeks that he's spent saving. Your rate is both those put together, the $15 saved every week. Okay, so now 15 is going to get multiplied with your x, and that's equal to your y, the total amount in the bank. Okay, last one. You've got this. And what a great one to end on. Beauty and the Beast down here. It says Belle and Adam, which, by the way, if you didn't know, Adam is the Beast's real name. Okay, so Belle and Adam are planning a wedding at the Disneyland Hotel. It costs a flat fee of $19,000. Then an additional $175 per guest that they want to invite. If they're planning on having 150 guests at the wedding, how much would the wedding cost? Okay, there's lots of numbers and info in here. Okay, is there a rate? What is it? Okay, the 175 per guest, right? So your rate is $175 per guest. So 175 is going to be multiplied times X, where X is the number of guests, right? And then your Y is the total amount of money for the wedding at Disneyland. Okay, so Y equals 175 times X. Now, is that it? Is it just 175 times number of guests? No, just for having it. Even if you only have 0 guests there and it's just you guys, you still have to pay a flat fee of $19,000. Okay, so the flat fee of $19,000 still happens regardless. So again, if this were 0 guests, 0 times 175, and just the two of you wanted to get married, it would be $19,000. If you have 1 guest, you have to pick your favorite parent. Okay, 1 times 175. 2 guests, 2 times 175, and so on. It's a pretty expensive wedding, huh? Let's say you have 150 guests. Okay, that's actually a modest wedding. How much is that going to cost you? Well, it would be, again, Y equals 175 times X, where X is 150 guests, plus this $19,000. Oops, plus sign there. And that 150 is multiplied by 175. So let's see what that is. First off, what do I need to do? I need to multiply this 175 times 150. So just to have all my guesses, how much is it? It's $26,250 plus that 19,000 just to hold your spot at Disneyland. Okay, so 19,000 plus the 26,000 is 45,250. And you're like, well, that doesn't sound as bad as I've heard. Okay, well, that's just like the bare minimum to have it there, to hold the venue, and then to have the guests. Now you still need to get food and flowers and music and the dress, all that other stuff. Okay, so that's just like your starting cost just to have it at Disneyland. Is it worth it? Miss Love says yes. No, I don't know. Okay. Remember that we said you're normally going to almost always use Y and X, but sometimes they specify, hey, instead, use G to represent this and C to represent that. Okay, then do what they say. If they specify something specific, use those. So I just need to decide, is the G like the Y or is it like the X? Well, G represents the number of guests. Well, it's $175 times the number of guests plus the 19,000 is equal to the total cost of the wedding. And there you go. Sometimes it's also helpful to write something that makes sense to you and then identify the independent and dependent variable that way. So that like, okay, it's this times the number of guests, so I'm going to plug in 150 for that. If you find yourself getting stuck because Y and X don't really mean that much to you. Okay. But at the same time, remember, you can always use that Y per X or Y every X or Y each X trick. Okay. Hopefully this has gotten you quite a bit more comfortable at writing equations from stories. You've got this.